these are the group members.
ठीक so next is that.
This is the topic determination of determination of lateral load capacity of masonry wall with openings using numerical modeling. These are the content we will present. Introduction, literature review, research methodology, purpose of where we will use, progress, next phase references. Introduction is first of I would like to talk about the background. Brick masonry is, we know that brick masonry is the most common used material in Pakistan, including and all over the world due to its ease of construction and low cost of construction. But in the past and also nowadays, there was no specific engineering knowledge used in the construction of brick masonry. Composite material, the composite nature is due to the materials that we use in brick masonry, like we use masonry blocks, bricks and blocks, stones also, and the other material is the cohesive material, which is mortar. The performance of brick masonry, it is very good when it is subjected to gravity loads, like it is used as a load carrying mechanism, and when it is subjected to incline lateral loads, they show poor results. Advancements, since as I said that they are poor in carrying lateral loads, so different models have been tested so far. Experimental works have been carried out. Also, numerical models have been carried out. Like there are many softwares using finite element methods. Abacus, ANSYS, these are the softwares. But we will use Abacus in our this work. Problem statement of history of earthquakes in Pakistan. Pakistan has faced many earthquakes, but the 2008-5 Kashmir earthquake was the most severe one. Like it put around 73,000 people into death and around 80,000 people were injured. A lot of people got homeless. Also, this is October 2015. There were a lot of casualties due to this earthquake, and schools and homes were damaged by these earthquakes. Most of the structures that were partially damaged or collapsed when studies were carried out, they were of brick masonry. Most of them were unconfined and unreinforced masonry. Like these factors affect the strength of brick masonry, unconfinement, unreinforcement, and walls with openings also affect the lateral load carrying capacity of brick masonry walls. Objectives would be numerical model of brick masonry with wall openings. We will model different walls with different openings, and we will show the study the results that how if openings affect the lateral load capacity. Now I would like to invite Junior the individual.
So there have been a lot of literature work on this, especially from the last decade and 1.5. This topic is a hard one. So even like experimental and numerical work is really in progress. So as our topic is numerical modeling, and there have been a lot, particularly these three methods, the discrete element method, finite element, and applied element method are used nowadays for numerical modeling, in which we choose the finite element method as it is simple and it gives the required result pretty fast. So finite element method, it is a method which is used to solve the different differential equations which arise during our solution of real world problems. So after as we have choose this method, now what kind of modeling techniques? And the popular modeling techniques are micro scale model, simplified micro model, and macro scale model. In micro scale model is the most detailed one. In this model, we model the brick unit, the mortar, and the interface material separately, and their interaction and how they react. They are added to software individually. In simplified micro model, we exclude the mortar and increase the length, half brick unit on both sides, so the mortar layer is diminished and the interface layer is selected. The mortar is selected as continuum linear material and no sorry, the brick unit is selected as continuum linear material and the interface is a non-linear material. Next slide. And finally comes the macro scale model, which is the most common in use because its computational efforts and its analysis is pretty fast. In this model, we take the whole model as a simple one unit and continuum. And for this method, we have to first perform experimental results to attend for proper calibration of the system. Furthermore, we move to the different failure modes in the brick masonry. The first one is sliding shear failure. This occurs exactly when the axial gravity loads are smaller. So in these cases, and there are chances of bed slippages, because the masonry walls are really have small strength in shear. Second comes the diagonal cracks. These tensile stress develop when the wall is both under the combined effect of lateral and vertical. And in these cases, the units are more prone to damages. And then there is the toe crushing, which occurs mainly when there is the bed at the bottom of foundation is not fixed. So our research methodology is what? First, the detailed literature review, which is already conducted. After that, we have the method FEM, and in this method, we will use a work software. First, we will calibrate our software results with Dr. Javed's experiments, in which he used a wall without openings. After the calibration, we will model the wall with openings, and then the failures and the results will be shared. The next will be explained by Hani Fuzan.
Abacus is a software which is used for finite element analysis. It is both used for linear and non-linear analysis. It can simulate problems such as heat transfer, mass diffusion, thermal management of electrical components, like ballistic, soil mechanics, and geometric module. There are different modules in Abacus software, like part module, property module, assembly module, step module, interaction, visualization, sketch, job, mesh, and load. In part module, we define different elements. In property module, we assign different properties to the materials. In assembly module, we assemble all the elements. And the step module, we give the steps for the analysis and the required output. And the interaction module, we give the contact properties between the different elements. In visualization, it's carried out after we. Okay, this is the view of the Abacus software. The progress we have made till yet is till March 2022 is developing numerical model starting from literature review. The rest will be carried out in the future. This is a model which is experimentally carried out by Dr. Javed, and we have calculated its numerical calculations, quantification. Geometry for the modeling, we have modeled this element by two different elements. First is the beam, and the second part is the wall, which is both are joined through which are both joined homogeneously. This is a second model, which is micro modeling, in which four parts are defined. First is RCC, beam, foundation plate, and half break, full break. The property module, in which there are two properties: sand break properties and the concrete. In the break properties, we have defined density, breaker values, and the breaker hardening values, and the elastic values for breaks. And there okay. In step, we have assembled the elements in this way, and we have defined different reference points. The first one is defined for in which we will apply the load, dynamic load, and the second part in which we will get all the reactions. Also, we will have displacement in the forces here, the reaction after analysis. This is the contact properties, which is the foundation plate is fixed. The wall is foundation plate is fixed with the reference point 2, and the bricks have been assigned with tangential behavior and normal behavior. This is the parts of our loads in which we have applied the pressure load about 103 psi, and the other loads are lateral load here with the reference point 1, and the displacement we have applied here, which is 20 centimeter, no, 20 millimeter, and okay. Mesh module, we have created a mesh in this way. Next phase, we will analyze wall without opening. In the next phase, so far we have done only without opening. Without opening, we will analyze in the future with opening, compare the result with already conducted studies, deliberations, model the wall with different opening area percentages, analysis and results. This is the references in which we have studied so far.